Hello friends, in this video we will talk about the new comparing feature which has been introduced in Java 8. For that, let's consider this employee class. In this employee class, we have three fields: employee ID, name and age. Let's suppose in our application we have a requirement in which we need to sort the objects of this employee class by employee ID. Before Java 8, we were used to implement a comparator in which we will we will override a method called compare and write the code which will compare employee ID. So let's see this how we were doing in before Java 8. We will write an implements comparator, we'll say integer, and now I will override a method called compare. Give some good name, employee ID 1 and employee ID 2, and let's compare it. Let's compare it here. Employee ID 1 dot compare to employee ID 2. This was the standard way before Java 8 by which we could compare the objects of employees based on their employee ID. So in this approach, there were some disadvantages. The disadvantages were this approach was very verbose, in which I will have to implement an interface and write some code in this. Second, the, the second disadvantage was this approach was scaling with very difficulty, because let's suppose tomorrow the requirement changes which asks us to sort the employee by their age also. So in that case, I will have to write a new class which will implement the same comparator and sort them by their ages. Then a new requirement comes which says sort the employees by their name also. Then I will have to write a new class which will compare their names by their by I will which I'm sorry. So which will implement the comparator and by of using string and compare their names. So this was very verbose. This approach was very verbose, and we had to write a lot of classes, which was time consuming. So in Java 8, they addressed this problem in a very fantastic way. So in Java 8, they made two major improvements. So they introduced the sort method in the list interface and a comparing method in the comparator interface. So I will reiterate here that in Java 8 we also got a new feature where we could write static methods in an interface. So public static methods we can write in an interface, and we can see that a comparing method has been introduced in comparator interface, and also we got a list interface, we got a sort method in the list interface which takes an object of comparator.comparing. So before walking you through this this piece of code, I would request you to watch this video till the end because in the next 2 minutes I am going to show you some more features of this sort method. What we can do some interesting things with this sort method here. So if you observe this employee class, I have a constructor which takes employee ID, name and age as a parameter. So I am creating 4 employees here who their names is George, Beckham, Ellen and Donald, and I have given some IDs to them, and I created an array of employee objects. I converted them arrays into a list by calling the method of arrays dot aslist and converted the array into a list, and I called it employee list. Then on this employee list I called a sort method which took the parameter of comparing here in this. So what does this comparing method do? This comparing method takes a key extractor. So a key extractor is nothing but a function whose return type is used by the sort method to compare the list objects. I will repeat. This comparing method takes a key extractor whose return type, so a key extractor is a function whose return type will be used by the sort method to compare the objects in the list. So, so what is the sort method doing? It is taking a comparing object, it is taking comparing object and comparing is taking the key extractor here. So in this case, when I want to sort by ID, I will use the employee ID as the key extractor. So I am saying here that sort all the objects in this list by the employee ID. Similarly in this, I am saying sort all the objects of employees which by age, and similarly by here by name. So things to keep it in mind here is the sort method has a return type of void. That means whatever the sorting operation it is happening in the same list. It is not returning a new list. So this object is getting changed. The list object is getting changed here. So you're not getting a new list. All the operations are happening on the same list object. So whatever the values get sorted here, the same list object will be used here. So if they are sorted here by IDs, you will get whatever the list it will be sorted here by ID, and then it will be the same list of objects will be used to compare the age here. So so you saw that in Java 8 how easily we can do this comparing. So we don't have to write a lot of code. Now the list so now there is a change in requirement. Now the requirement is we should see we should also have the flexibility to see the employee objects in the reverse order. But before seeing in the reverse order, let's run this example and just see how the data is displaying. So by the sort by ID, it is sorting it properly by 1, 2, 3, 4. By sort by age, it is sorting the objects in their ascending order of their age 29, 30, 31, 32. So it is sorted. And when we say sort by name, it is properly sorting by their name, Alan, Beckham, Donald, George. Now let's come back to our problem that we have a new requirement here that which says that sort the objects of employees by the descending order of their employee ID. That means 5 should come, 4 should come before, then 3, then 2, then 1. So in this case, we have flexibility here. Now there is a new method which is introduced which says reverse, and let's see what happens. When I run it, it sorts it in the reverse order. 4, 3, 2, 1. It is that easy. Now let's say there is a new requirement. Now there is a new employee added in our list whose name is Christopher and his ID is 5, name is Christopher, and his age is same as Donald. His age is same as Donald. Now let's run this set of data and provide it to our program. What happens? You see here, by age, Donald and Christopher have the same age and they are sorted by their IDs, like 4 is coming before 5, so Donald is coming before Christopher. But let's suppose we have a requirement that when there is a tie in the age, if two people have same age, sort them by their name, not by their ID. So Christopher should come before Donald because they have the same age. So in that case, what we are going to do here? So the comparing method has something called then comparing. That means when you have a tie on age, then how do you want to sort the object? Then in this case, we will say employee dot get name. So by this, we are saying when there is a tie on their age, sort the name of the employees by their names. So let's see what happens. So when we are sorting it by their age, there is a tie between Christopher and Donald in their ages, and and the way we implemented it has sorted the objects by keeping Christopher first, then Donald, and which was our requirement. So in this video you saw that what are the how easy it is to compare the objects. So there is now one more last improvement which can be done in this is if we import this comparing method. Since this is a static method, we can use import static compare dot comparing, and so now we don't need to use comparator in this. In this way. So this is a very optimized code, and we can remove the comparator here. So now if you see, this looks very clean, very to the point. Code is very to the point here. So just comparing, and it is self-explanatory. Sort the sort the list of employees based on comparing this. So hope you like this video. So in this video I will brief it at the end. So in this video we saw the use of newly introduced method sort in the list interface, and we used the newly introduced comparing method in the comparator interface, which has reduced our comparison code to a great extent. Thanks for watching this video.